Hello everyone, this is Ashwin here. In this video, we are going to see on how to build a neural network for predicting age and gender. Here we have a UTKFace dataset. In this dataset, we have around 20k cropped images with the age, gender and ethnicity. We are going to use only two output labels, that is age and gender. So gender is like a classification problem and age is like a regression problem. So we are going to do both of them at the same time in this project. So let's see the data set. Here they have mentioned all the details, and we also need to get the labels from the file names. So here you can see all of the faces, and there are from different angles also, as you can able to see. And here from the labels you can see 100 is the age, and 0 is the gender, and the third one is the ethnicity. So we are going to ignore this one. So we are going to get the age and the gender. So here 1 is female, 0 is male. That is clear for us, and with the help of these labels we are going to build our data set. And that is all about this data. I think we can jump into the code part. And you can also build various tasks with this. So here they have mentioned face detection, age estimation, age progression or regression, landmark localization, etc. So here we are going to just focus on age estimation and gender detection. That is the two tasks we are going to do here. And yeah, here we have like two parts. One is UTKFace and another one is crop part. We are going to use only the UTKFace. Now let's jump into the code. So here we are using a Kaggle environment, and we can directly load the dataset from here. So here you can see this UTKFace new. So from here we can directly get the dataset. And I am also enabled GPU for this notebook, because we are going to deal with neural networks. So enable the GPU, it will speed up the process. And that's everything, guys. Now let's jump into the code and start importing the modules first. So import modules. Now here we are going to import all the basic modules first. So I'll quickly import, because we have seen this like so many times. Import numpy as np, import OS for file processing, import matplotlib.pyplot as plot, import seaborn as SNS, import warnings from tqdm.notebook, import tqdm. So this is just for getting the loading screen or the progress bar while loading the images. And as usual, warnings dot filter warnings ignore. So this will give us some clean results. And matplotlib inline. So these are the basic modules so far. So these are the basic modules we are going to use. Apart from that, we have to import few modules for the neural network part. Before that, we will import TensorFlow as TF, and from Keras dot preprocessing dot image import load image. So this will just directly load the image into a NumPy array. So from Keras dot models import sequential and model. And apart from that, we have to import few layers. So from Keras dot layers import dense con2d dropout flatten max pooling 2D, max pooling 2D, and input. So we are going to use some different kind of neural network here because we are going to do both classification and regression in same model. So that's why we are going to use two different outputs for this neural network. Usually we'll be having like one output or one type of problem, whether it's like a classification or regression, but here we are going to go with both of them. Let's run this. So this will import all the modules. After that, we will load the data set. Okay, now the modules have been imported successfully. Now we will create the basic directory to load the images or the data. Now just copy this and paste it here, and it also contains UTKFace, UTKFace/. So this is the folder containing all the images. So we will use this variable. Now we have to load all the images along with the labels. So we will create 3 lists. So age, gender, and ethnicity. So these are the labels that the image have. Labels. Now I'm going to create like 3 lists. So one is for image paths, and second one is age labels, third one is gender labels. So here we are going to store everything. Now for file name in tqdm of os.list directory of the base directory. Now this will iterate all the files inside this particular directory. Now we will get the image path. So image path equals os.path.join. I'm just combining the directory and the file name here. So again base directory, and here I will combine the file name. Now we will get the image path here, and after that we will have a temporary variable, or it's like a list. So I'm going to split the file name into like multiple parts. So file name dot split based on underscore. I am using underscore. So here you can see this is like a image ID, this is age, this is gender, this is ethnicity. So I'm just splitting everything based on this underscore. Now if you do that, we will get the age equals int of temp of 0. So this is the age, and this is equals, and after that we will get the gender. So int of temp of 1 gender. Now image paths dot append of image path. After that age labels dot append of age, and gender labels dot append gender. So this will add the image, that is the input, and this will add the age and gender. These two are the output. So we will run this. Okay, it loaded all the images in a blink of an eye. So this is quick. So it has loaded around 23,700 images. Now let's convert it into a data frame. So convert to data frame. df equals pd dot data frame. Now df of image, df of age, df of gender. So these three are the columns I'm going to create. So we will have image paths, age labels, and gender labels. So you can also assign it like in 3 separate lines. I'm just using single line to assign everything. So image paths will be assigned to this one, age labels to this, and gender labels to this column. Now after that, let's see the head. So now we have created a proper data frame. Now you can see this is the complete path of the image, and this is the age, and this is the gender. So that is done. Now we are going to create a gender dictionary. So map labels for gender, gender dict equals 0 represents male. We already seen in the data set. So that is male, and 1 represents female. So this is the gender dictionary. So when we are trying to predict or display the images for EDA, we will use this gender dictionary to display the corresponding labels. So it will be clear for us which is male or female. This is just for interpretation for us. Now run this. So somewhat slow. It's okay. Now we will go with the exploratory data analysis. Exploratory data analysis. First, I am going to display only one image. So for that, from fill import image. So this is the module I'm going to use. So img equals image dot open of df of image of 0. I'm just loading the first image. Now plot dot axis of. So this will remove the axis, that is with the numbers. Now plot dot im show of image, and a semicolon will remove the additional text. Okay, now you can see the image. So this is the first image, and we have a smaller image only. I think 200 cross 200. That is the image size. We can also resize to some uniform width and height. I'm going to resize it with 128 cross 128 just for loading into the RAM, because we have limited resources here. Here you can see we have GPU 16 GB, but RAM is only 13 GB. So if you load everything in a RGB format, means it will cause memory issues. That's why I'm going to use a grayscale image with 128 cross 128 for better processing. Still, we will achieve some good results with this pre-processing of data. Now let's see the class distribution. So first, SNS dot distplot. So df of age. So this is the age distribution. It's around from 0 to 120. We have the age ranges, but most of them are around 25 or 26, something in the range have like highest. And the curve is like a normal distribution, but skewed on the right side because of these few less number of samples. But if you consider 0 to 80, means it is falling under normal distribution. That is fine. You can also convert this age into a scaled format, like standard scalar or min-max normalization. You can do it in order to get the numbers in the range of 0 to 1. So we will deal with this later, and after this we will get the classes, that is male and female. So that is SNS dot count plot of TF of gender. Now almost both of them have uniform distribution, like both are almost having same number of samples. It's around like 11,500. This is around like 12,000. Not much of a difference. So it is a balanced class distribution. Now we will see a set of images, like the first 25 images, in order to explore the data. You can also shuffle the data if you want. So that is also possible. Now, so to display grid of images, now plot dot figure fig size of 25, 25. We can adjust this later also if you want. Now files equals df dot iloc of 0 colon 25. So I'm just getting the first 25 images, and again you can also shuffle the data if you want. Now for index comma file comma age comma gender in files dot iter tuples, I'm just iterating the data frame. So this is like a filtered data frame. I'm just iterating all 3 columns. If you use iter tuples means it will also gives you a enumeration like this index. So this will be useful for plotting. So plot dot subplot of 5 comma 5, that is 25, and index plus 1. So index should start from 1 for this subplot. That's why I'm just adding 1 here. And after that, I will load the image. So image equals load image of file. I'm just loading it as like a array. So img equals np dot array of image. Now plot dot im show of image. Here plot dot title of format. So we can specify the format here. I will display the age and gender. Here we are going to use that dictionary. So gender dict of gender. So this will give us the corresponding string for the gender. So after this, we are going to use plot dot axis of, run this. So this will just ignore the numbers or the axis. So we will get only the images. Now you can see male according with the gender, female gender, and you can clearly see the age difference also corresponding with the image. So everything is displayed in a good manner. Maybe we can compress it to 20 cross 20, so it will be easier. So 20, run this again. Okay, now it's somewhat compact, and also you can see all the images clearly. So that's good. After this, we are going to do feature extraction. So feature extraction, I'm going to define a function here. So def extract features of images. I'm just going to pass the images alone, and here features equals a list. Now for image in tqdm of images, so I'm just getting each path one by one. So image equals load image of image comma grayscale equals true. So why I'm converting to grayscale is if you load it as a RGB means we will be getting 3 dimensions. But I can't able to load all the images here, because it will just load up all the memory and the session is crashing. That's why I'm just using grayscale images. So we will keep it in like a single dimension. And after that, image equals img.resize. Initially I think it's 200 cross 200. I am just reshaping to 128 cross 128. And while reshaping, we may get some distortions. To avoid that, we will use anti-alias. Okay. Now after that, img equals np.array. Everything we are going to deal with the arrays only. So that is done. And finally we will add it to the features dot append of image. So after doing everything, finally we will convert the features to a numpy array of features, because the neural networks can handle only the numpy array. And again, features equals features dot reshape of len of features. So I'm just reshaping here, because the neural network will take a particular input feature. So the first one represents the number of samples, second one represents the dimension, so width and height. So third one represents whether it's a RGB or grayscale. RGB means you will be giving this as 3, or by default it will be having this 3. So if you are using grayscale means initially the shape will be like this, the number of features, width and height. So for grayscale you just need to convert this to 1. So with this shape only the neural networks accept. So while you are getting the image as a RGB means, by default it will get the shape as 3 here. So you don't do this if you are using a RGB image. Ignore this step if using RGB. Currently we are just using grayscale. After doing this, we will return all the features. Run this. So this is the function we are going to use. X equals extract features of df of image. Let's run this. Now this will take some time, because we have around 23k images. In the meantime, we will display few things. Anyway, we have to wait until this completes. We will just get the syntaxes in place. So x.shape, we will check the shape of the data, and after that we have to do normalization. Normalize the images. So for that, x equals x divided by 255.0. So because the pixel value is in the range of 0 to 255, that's why I am just normalizing. So it will be in the range of 0 to 1. Now after this, we also need to convert this gender and age to a numpy array. So I will call it as ygender equals np dot array of df of gender. And again, I'm making some mistakes here. And y age equals np dot array of df of age. So we will run this once this completes. In the meantime, we will get the configuration. So input shape will be 128, 128, 1. And again, if you are using RGB, just have this as 3. Output class class, I think both of them will be 1, so we will just leave this and this. Okay, I mistakenly ran this. Sorry, I interrupted this, so we have to do this again. Now it's loading much faster. I think it cached a few images. Okay, in the meantime, we will do the model creation. Model creation. So this is a convolutional neural network. I'm going to use image as an input, and we'll be getting 2 outputs. One is for classification and the other one is regression. So we are going to specify 2 different loss metrics here. So first we will get the inputs. So inputs equals input of input shape. First we will get the con 1. This is convolutional layer 1. I will have con 2D of, first we will get like 32 filters, and kernel size equals 3,3. Activation equals ReLU. So this ReLU activation definitely improves the model performance. I have checked it with different models, so including this activation layer definitely improves the performance. So be sure to include this. So I will pass the inputs here, and after that I will get max pooling. So max pooling 2D, pool size, pool underscore size 2,2, and here I will pass the convolutional layer. So this is the input, this is the output we are getting, and from this output I am just passing here as an input. So this will keep on going like multiple times. So I'll just copy and paste this like 4 times. Again. Okay, it ran successfully. Just run these things. Okay, this is the shape. As I mentioned, this is the length of the features, width and height, and this is the grayscale. That's why we are having 1. Normalize the images. Convert to NumPy. Initial the input states. And I'm getting some error here. Okay, now we have to change a few things. So this will be max p. So this will be max p 1. This will be 2. This will be 3. And here similarly convolutional 3, 4. And here 2, 2, 3, 3, 4, 4. So everything is good to go, and we will just change the number of filters here. So it will be 64, 128, 256. So these are the convolutional layers. Convolutional layers. And after this I will flatten everything. Flatten equals flatten off. I will pass the max pooling 4 here. So flatten means it will the convolutional layers have the weights in terms of like matrix like structure. So flatten converts into like a single dimension vectors. And after that we will create dense layers or fully connected layers. So dense 1 equals dense of 256. Activation again relu. I will pass the flatten output here. Similarly, I will have the same thing for the second output. So this will be dense2 with the same dense layer, and I will follow the flatten, and we need a dropout layer also. Maybe after this we will add the dropout layers. So dropout 1 equals dropout of 0.3. This will have some regularization. So I will have dense 1 here, and similarly I will have this for dense 2 also. 2. Finally we will have the output layers. So output 1 equals dense of 1 output. This can be the classification or the regression. So activation equals sigmoid. So this is for the gender. Sigmoid comma name equals gender out, and I will pass the dropout layer here, dropout 1. Similarly, we will have the output 2 for age. So output 2, we will have like a numerical value here. This can be relu, and here I will have age out, and this will be dropout 2. Okay, this is good to go. So this is the output layer. Now we have to compile everything into a single model. So model equals model of inputs equals inputs, and outputs equals output 1 and output 2. So this is the model. Finally we will just compile the model. So model dot compile of loss equals binary cross entropy. So this is for binary classification, that is the gender, and another one is for MAE mean absolute error. This is for the regression. So here I will have the optimizer as Adam. You can also change it to SGD if you want, with some momentum, and metrics equals accuracy. So for the regression we can use this mean absolute error as the metric. So both the loss and the metric will be the same for this age. Only for the classification we will be using different metrics. So for loss we will be using binary cross entropy, and for the metrics we will be using accuracy. So that's everything. Okay, just throws these, run this again. Now that's done. Now model dot summary. So this is the layers we are having. So apart from that, you can also like plot the model. I think we can include that function. So I'm going to import one more module here. Instead of using the summary, plot the model here from keras.utils import plot model. I don't know whether it's suggesting plot model. Now plot model of model. Run this. Okay, it's not importing. Let's see. From tf.keras.utils, from tensorflow keras.utils, import plot model. Now you can see the whole model here. This is the input layer and all the convolutional layers. So finally we are having like two outputs. So here using this, so this is gender out and this is age out. So this is the whole model, and after this we will train the model. So train model equals history equals model dot fit of x equals x, y equals, we will be having like two outputs. So y gender and y age, batch size equals 32. You can also mention 64 if you have good memory. Epochs I will have around 30, and validation split equals 0.2. So I will use 80% for training, 20% for validation. Now run this. Now the epochs is starting, I guess. Let's wait for the first epoch. Okay, it started and it's giving out the loss for gender and age. It's also giving out gender out accuracy, and here you can get the validation loss, validation gender loss, validation age out loss. So based on the loss we have specified, we can use this, and here you can get the accuracy. Just get the accuracy for the gender because that is the valid one. We already got around like 80% accuracy. That is much better. I think it's 85 now. Okay, let's leave this as it is. Now we will plot the results. Okay, now we have to like get few things. Maybe we will just wait out until this training completes. Okay, now the training has been completed. Here you can see the validation gender accuracy is around 89. Here we can go up to like 89.5. That is the highest validation accuracy for the gender. I think it's around 90. You can increase the number of epochs to get some good score. For the training gender out accuracy, it's gone up to 96. I think even if you increase the number of accuracy, I think it converges at this point. Yeah, I think that's a good accuracy for us for gender. And for the age, here we can see it's around 6.6. That is the mean absolute error for the age. So that is the metrics we are going to use. Let's plot the accuracy and loss graph here. So to get that, I will say accuracy equals history dot history of gender out accuracy. So this is for the training accuracy. For val accuracy, we will have the same. Here we will have val gender out accuracy. Now epochs equals length of, okay, range of length of accuracy. So based on the number of samples, we can get the number of epochs. So that is the point here. So plot dot plot epochs comma accuracy, color will be blue. I will call this as training accuracy as a legend. So training accuracy plot epochs comma val accuracy label equals validation accuracy. Now plot dot title, this is accuracy graph. Again plot dot legend, this will show the legend. Now plot dot figure, this will display the image. Now we can copy and paste the same thing. Okay, here instead of accuracy we will use it as loss. So just replace it everywhere. We don't need the epochs. So this is accuracy, and here we will get the training loss. This will be loss graph. Instead of figure we will say plot dot show. Run this. Now this is the plot we are getting. Okay, so this is the training accuracy and this is the validation accuracy. It's saturated, it's around 90%, and the training accuracy gone up to like 96%. And here in the loss graph, here you can see it is saturated around like 0. Gone up to like 0.3, and it's shot up here. I think we have to decrease the number of epochs if you want to get it. Like I think 15 is like a reasonable number. Okay, here for the loss, the test validation loss is just shorting up, and the training loss it's keep on going down. I think we can decrease the number of epochs to like 15 itself in order to get the maximum accuracy with the loss. So this is for the gender. So plot results for gender. So for the age we can just print only one graph, plot results for age. So for the age I am going to use only val age out loss and age out loss. So these are the two things. So here I'll just get this. Now for this I need this number of epochs based on the loss, training loss, validation loss. This is for age, right? So age. Okay, everything is good to go. Run this. Okay, I think even here the training loss like keep on decreasing, but the validation loss is like saturated at 15th epoch itself. I think 15 is like a optimal epoch. If you train more means it may go for overfitting, or it's useless if you like go further. What you can do is you can use some different optimizer in order to find the global minima. Currently I'm just using Adam. This is the results for Adam. You can use SGD with learning scheduler in order to get some different results. If you get some different results means please leave a comment below. It will be very helpful for others. Now finally, prediction with test data. I'm gonna use like normal some random image here. So including visualization, I'm going to use it here. First I will have the image index, image underscore index equals, I will have 100. You can randomly get the images if you want, so that is also possible. I'm just specifying the index here. First we will print the original gender and age. So print original gender, that will be, we have to get it from the gender dict. So gender underscore dict of y gender of image index. Okay, now original age, that will be y age of, age is a numerical value, that's why I'm just directly getting the age. Okay, this is the original. Now predict from model. So I'll say prediction equals model dot predict of x of image index dot reshape of 1, 128, 128, 1. So we are just passing only one image. That's why I'm just changing the number of samples as 1. Or else if you want to predict everything, means you can just pass the x alone. So currently I'm just passing only one image. So this is the syntax for that. After getting the prediction, we have to separate the gender and the age. So prediction gender equals, again we will use gender dict of round of, because it will be in the form of 0 to 1, that's like a probability. Anything above 0.5 I will consider as 1, that's why I am using round off function. Anything below 0.5 I will consider that as 0. And again prediction of 0, 0, 0. So it will be giving the results in like a multi-dimensional format. In order to get the value from the array, I'm just using multiple indexes. So you have to go into like 3 index. And for the age, prediction age equals, again round off, because age won't be in decimal. Prediction of 1, 0 and 0. So inside the prediction we'll be getting like 2 outputs, right? That's why 0 will be his gender and 1 will be for age. And these additional subscripts is just to get the value inside the from the array. So that's that. Finally print predicted gender. It will be pred gender, and predicted age, so pred age. Now plot dot I am show of, again x of image index dot reshape. Here we just need the width and height, 128, 128, and C map equals gray. I'm just displaying in terms of a grayscale. Okay, dict object is not callable. Okay, this is, it should be like a subscript because this is a dictionary. I just called it as like a function. Okay, if you want to ignore this matplotlib, just add a semicolon here. Now you can see. If you want to remove this plot, maybe we can say plot dot axis of. Okay, now we got the clear image. So here the gender is female. It predicted correctly. Original age is 3, but the predicted age is 1. That's fine. It's like a close difference only. Again, we will see with a different index. I will go for 5000. Maybe 3000 is fine. Now this is again the original gender is male and predicted gender is also male. So prediction is correct, but the age is around, yeah, it's closer. So original age is 28, predicted age is 32. So it's definitely closer. Let's see for another. I will have 5000 or 10,000. This is just the index, and again you can get it in a random manner also. Okay, here again gender is correct, male. Age, again it's having like a 4 difference. I think it's like a residual error. Maybe we can fine tune this later with a separate model also if you want, but it is close. We can like clearly judge a person age just by seeing the face, right? So that is also there. So it's giving us a good result so far. So this is the whole project. We have done everything in an end-to-end manner. So that's it, guys. We have seen how to build a model for predicting the gender and age with a single neural network itself for both classification and the regression. If you have any more ideas on this, means please leave a comment below. Apart from that, if you like this video, hit the like button and don't forget to subscribe the channel for more videos. Stay tuned for the next video.